Hi class, welcome to review for the periodic table test. As in all reviews, in bold we have the major understandings. These are the big ideas you should study before the test. After that, we have some practice questions. Let's get started in looking at some of the major understandings and the big ideas about how the periodic table is arranged and the major parts of it. Okay, so moving on to question number 9, it asks which element has chemical properties that are most similar to the chemical properties of sodium? So here what we're looking for is similar chemical properties, and we're looking to sodium, and sodium has atomic symbol Na. So what we'll do is we'll look at the periodic table and see if we can find some sodium. Looking at the periodic table, you can notice that the elements are arranged in increasing atomic number. Now, important parts of the periodic table are labeled. So periods represent rows, and groups represent columns. Very important geographic location on the periodic table is the bold zigzag staircase. This bold zigzag staircase separates the metals, the nonmetals, and the metalloids. For the elements that touch the bold staircase on two sides, with the exception of aluminum, are called metalloids. Shaded in blue are the metalloids. Everything that falls to the left or under the staircase are metals, including these inner transition metals. And everything that's above or to the right of the stair steps, these are called nonmetals. When looking at our periodic table, we'll notice two interesting trends. The first trend being that all the elements in the same group tend to have the same number of valence electrons. Now when we look across the period, we'll see that the atomic number changes, but the number of principal energy levels, or the number of rings of electrons in the Bohr model, remains constant. So here we find sodium, and we can see here from our notes earlier that elements in the same group have similar chemical properties because they have the same oxidation number and the same valence number. So what we're doing is we're looking for an element that is in the same group, the same column as sodium. So here we have the question, and we see that magnesium is not in the same group as sodium. Now selenium is also not in the same group as sodium, so we'll eliminate selenium as a choice. Potassium is in the same group as sodium, so potassium is our answer. And then we see chlorine. Chlorine, which is over here, is not in the same group as sodium. The next question asks us to evaluate elements in group 2. So again, we need to refer to the periodic table. So here we have a little image with group 2. So remember, our periods are rows and our groups are columns. So we're going to look at group number 2. And here, mass number. So the mass number is a whole number. It's not actually listed on the periodic table, but it's similar to the mass here. And we can see the masses are different. Now, atomic number, that's the very important proton number that is bolded on our periodic table. The atomic number is different. Now, remember that the number of protons is the atomic number. We learned that last unit in the atomic structure unit. Can't forget that. And then lastly, we have the number of valence electrons. Remember that the number of valence electrons is the number of electrons in the outermost principal energy level. So in the electron configuration, it'll be to the right. We can see beryllium has 2 valence, and magnesium has 2 valence, and calcium has 2 valence. So here, the number of valence electrons is the best answer. Question number 11 and 12 ask us to refer to the elements sodium, argon, arsenic, and rubidium. And it asks which two will have the most similar chemical properties. Recall that similar chemical properties are found in elements that have the same oxidation number or the same number of valence electrons. So they'll have to be in the same group. Looking here, I noticed that sodium is in the same group as rubidium. So they will have the most similar chemical properties. Now, and it asks to explain this in terms of the periodic table. So they have the same oxidation numbers. You can use that, or you can say they have the same number of valence electrons. Finally, the next questions refer to the major trends on the periodic table. You'll want to make sure that you understand the definitions of these trends. So the atomic radius is how large an atom is. Now that is controlled by the different parts of the atom, both the nucleus, the positive center, and the number of electron shells that surround the nucleus. Now, ionic radius is obviously the radius of an ion. Remember that atoms gain or lose electrons to form ions, and ions have stable noble gas electron configuration. Basically, with ionic radius, it's important to remember that since metals lose electrons, their ions are smaller than their atoms. And since nonmetals gain electrons, their ions are larger than their atoms. Now, electronegativity is the measure of attraction for electrons in a bond. That is a value listed on reference table S. The first ionization energy is the amount of energy required to remove an electron from an atom, and then non-metallic or metallic character refers to whether or not they tend to gain or lose electrons. Okay, so let's look at question number 13. It asks, as elements in group 17 on the periodic table are considered from top to bottom, what happens to the atomic radius and the metallic character of each successive element? So what we'll want to do is we'll want to look at group 17. So the question states that we should be looking at group 1 in order of increasing atomic radius. Let's just find and circle the atomic radius of the first several elements in group 1. So here you can see I've circled the first several elements of group 1, and we can notice that as we go down the group, the atomic radius is increasing. So the question asks, in order of increasing atomic radius, what occurs with the first ionization energy? So let's just simply look at that. Here I've placed a red dot next to the first ionization energies. Notice that as the atomic radius increases, the first ionization energy generally decreases. The last question on the page asks, for alkaline metals, state the trend in electronegativity in terms of atomic number. So alkaline metals are group 1 elements. So if we look back at the previous image of the periodic table, we should get the same result. So again, we're looking here at group 1 metals, the alkali metals, but we're interested in the electronegativity. So here we'll just look at the electronegativity starting with hydrogen, which is 2.2, lithium 1.0, sodium 0.9, then we have potassium 0.8, and then we have 0.8. So they ask when, in terms of atomic number, the atomic number is increasing, our electronegativity is actually decreasing. So here we'll just fill in that electronegativity decreases.